In today's lesson, we're going to go back and take a look at exponential functions again, but we're going to try and approach them today without using any technology. We're going to use some ideas of logarithms and the idea that logarithms and exponential functions are connected to each other. Before we do that, let's just review what we did before with exponential functions from last unit. And we said we want to solve an exponential function, that is one that has an unknown exponent. If we can make our bases the same, then our exponents have to be the same. And that's what we did last unit on your last test. So for example, in the first one here, I want to make both my bases into 2's. I can do that. I'll guess and check. Tells me that 2 to the power of 3 is the same thing as 8. My bases are the same. My exponents are the same. So x has to be 3. That's a really messy 3 there. Sorry, guys. Okay, I can do something slightly more complicated. Again, if I want to make my bases the same, I can make them both into 3's. Okay, if I guess and check, 3 to the power of 3 will make 27. So that's another way of writing it. My bases are the same, so my exponents must be the same. We can set that up and solve that. And x is 1. And I can even do ones where the bases don't look the same. I can't make a 4 into a 32, but I know that both 4 and 32 are powers of 2. 4 is like saying 2 squared, and 32 is like 2 to the power of 5. And with powers to powers, we have to multiply our exponents. And then we can solve this equation, right? Get rid of your brackets. Rearrange the equation. 2x, 4 plus 5. We get 9 on one side. We get 3x on the other side. Divide both sides by 3. And x is 3. And this works fantastic. We've been doing this. We did this all last year. We solved things. It was not a problem. The only problem is when we come across situations where we can't make our bases the same. For example, 5 to the x equals 53. There is no guess and check of 5 to the power of anything that will make 53. That is not possible. Okay, so what we did last year was we went to our technology, right? We put this in Desmos and we said, here's one equation, here's my straight line, where do they meet? Well, I could do that if I have some technology available to me, but if I don't, I can use a logarithm. And the way we use the logarithms to do this is we use the idea of a base 10 logarithm and the power rule. That's the one yesterday we talked about with the log laws when I have something that looks like this. A base of something to a power. I can rearrange it and put the exponent in the front. In our case, because we're talking about base 10, and these aren't m's anymore, they're now the number 10, and that's something I can use on my calculator. Okay, so logarithms come in handy for things where we need technology, but we don't have technology. So let's take a look at the first one. The way it's going to work. I'm going to take the log of both sides. Why don't they do something on one side and do the exact same thing on the other side? I haven't mathematically changed anything. It's the same equation, just a different format of it. Now this looks like a log law idea. The x up top can come down front using my power rule. So we got x log 5 equals log 53. And if I want to solve this for x, I can divide the left side by the log of 5. But if I do to the left side, I go to the exact same thing to the right side. So on the left, I'll be left with just an x. And because these are base 10s, I can use my regular calculator, log 53 divided by log 5, and it comes out to 2.47. And we solved it without ever using technology. Okay, so you guys try the second one, see if you can figure it out. Same idea, just different numbers. I know I'm using this idea if I can't make my bases the same. If I can make my bases the same, I can use exponents. But there's no way I can make a 2 into a 364. Okay, so we take our log. Our log of 2 to the x. It has to be the log of 364. The x can come down in front. Everything else stays exactly the same. To solve for x, I get to divide by log 2. If I divide one side, I have to divide the other side. I take out my calculator, I punch in log 364, divide by log 2, and I get 8.51. And there's our answer. Done. Quick. Probably faster than technology in some ways, right? Don't have to worry about our zooming in and zooming out. Okay, we can do some messier things with these also. Okay, our exponent can involve more than one part. Again, there's no way I can make a 5 into a 130, so I know I'm using a log. So I'm taking the log of 5 to the 2x plus 3 Log on one side, log on the other. The exponent comes down in front. Now my exponent is all of this, right? 2x plus 3. So I'm going to put in brackets. Times the log of 5 equals the log of 130. I want to get x by itself. So I'm going to divide out that log 5. I'll be left with a 2x plus 3 on the left side. Take out my calculator. I get 3.02 on the right side. Now, yes, I have decimals, but these are decimals I can work with, right? This is just basic algebra now. Numbers on one side, letters on the other. 3.02 minus 3 is 0.02. Divide both sides by 2. And x is 0.01. Okay, and I solved something that I wouldn't otherwise be able to do without technology. Okay, take a look at D. Now, D is slightly different because it's made up of two parts on the left-hand side. There's not just a base, there's a base being multiplied. In order to use this log law idea, I need to have it looking like just a single base. So I need to get rid of the 50. How do I get rid of the 50? Well, right now it's multiplying. So I'll divide it. If these two divide, they cancel out, right? But if I divide one side, I have to divide the other side. Okay, so on the left-hand side, I have 2 to the x over 5. On the right side, 350 divided by 50 makes 7. Now I have a single base to an exponent. That means I can use my log laws again. So the log of 2 to the x over 5 should equal the log of 7. The x over 5 can come down in front. And I'm going to divide both sides by that log 2. I want to get rid of the log part. I'll use my calculator for that. And that's okay if I get decimals. Nothing wrong with decimals. On the left-hand side here, I'll have x over 5. On the right-hand side, log 7 divided by log 2 comes out to 2.81. I need to get rid of the 5. It's dividing, so it goes to the other side and does the opposite. It multiplies, right? 2.81 times 5. And punch that in our calculator, we end up with 14.04. That's how I solve something. Okay, so the big thing to note in this last one here is I need to have one base, just a single base before I take a log. If there's a number in front, I have to divide out, divide both sides by that. Okay, that's going to come in handy when we get to some word problems here. Just a second. All right, we got a sum of money. It's invested at 7% compounded semi-annually. You might remember this formula from when we did finance last year in grade 11. Okay, according to this formula, A is our amount, P is our principal. That's how much you invest. N is our number of years. I want to know how long it's going to take to double. So it doesn't really matter how much I invest. Let's say I invest $100. That'd be my principal. If I want that to double, my amount would have to be 200. Now you don't have to choose those numbers. You can choose any numbers you want, as long as your amount is double your principal. So we put those in the right spot in our equation. A is 200. P is 100. 1.035 to the power of 2n. Well, this looks like the last question we did. I want to have a single base on each side. I'm going to divide out that 100. And that way I'm left with just a single base on the right-hand side, 1.035 to the power of 2n. On the left side, I'll get 2. And no matter which numbers you choose, you should get 2 there, right? Because that's the idea of it doubled from 100 to 200, from 50 to 100, from $1 to $2, whatever it is. Okay? Now this is a perfect equation for using a log law. Look, we've got a base with an exponent. If I take the log of each side, oops, there's missing a letter there. Log of 2, the log of 1.035 to the 2n. I know that my 2n can come down in front. Okay, it's an exponent. I know I'm still left with log 2 on this side. To simplify this, I can divide out that log piece. Log 1.035, log 1.035. They'll cancel each other out. I'll be left with the 2n on the right. Take out my calculator, I punch that in there, and I get 20.15. And if I wonder what n is, again I got to do a little division, divided by 2, and I get n would be 10.0 0.75 years. Okay, and that's so we can solve some simple problems with exponential functions. I'm going to stop there for page 1, and then we'll do page 2 in just a second.